Ever notice how your eyes instantly pick out the edges of objects, even in dim light? The secret lies in a process called lateral inhibition. In this video, you'll learn what lateral inhibition is, how it sharpens your senses, and why your brain loves contrasts, whether you're seeing light or feeling touch. Here's the big idea. Lateral inhibition happens when an excited neuron reduces the activity of its neighbors. It's your nervous system's way of boosting contrast so you can detect fine details. In the eye, this happens in the retina. When light hits photoreceptors, the most activated ones, send signals through horizontal cells that slightly suppress their neighbors. This contrast makes edges look sharper and clearer. And while inhibition sounds like it would weaken your senses, it actually does the opposite. By reducing background activity, it lets the brain detect changes more precisely. Because what the brain cares about most is contrast, not overall brightness. This contrast effect is crucial in everyday life. It helps you read black text on white paper, see lane markers on a road at night, or notice shapes in a dimly lit room. Without lateral inhibition, everything would blur together, and sharp boundaries would be harder to detect. So far, we've seen how lateral inhibition boosts contrast and sharpness in what you see. Ready to lock it in? Tap the link for study guides and flashcards on this topic, so you can keep learning without missing a beat. The same idea appears in your sense of touch. In this system, each patch of skin connects to neurons in your somatosensory cortex. When one spot is pressed, its neuron fires, while surrounding ones quiet down. Zooming out, the brain's touch map, called the sensory homunculus, shows that areas like your fingertips have small receptive fields with strong lateral inhibition. That's why you can tell two pins apart even if they're very close. Even so, there's a limitation. If neighboring inhibitory regions overlap too much, their signals blend, and two touches can feel like one. That's the skin's resolution limit. To see how the sharpening helps, before you hit that limit, imagine running your fingers over two fabrics. One smooth, one slightly textured. Because lateral inhibition turns down background activity, your skin can pick up tiny pressure changes that help your brain tell them apart. Whether it's light or touch, lateral inhibition refines signals by turning down background noise, helping your brain focus on what matters most: change. To recap, lateral inhibition helps your senses highlight contrast, sharpen edges, and fine-tune details in both vision and touch. It's your brain's built-in contrast enhancer. Ready to quiz yourself with the content covered in this video? Check out the link in the description where you'll find Quizlet content made just for you.